friends, welcome to all of you. So here, if you remember in the last class, we have just started with developing a test case in OpenFOAM. So we have solved this geometry for Laplacian equation, and I told you that if you want to start with a test case, then you should have these three folders in your test case. Okay, only then you can use the OpenFOAM solver. Okay. So if you remember, I have told you about that 0 has the initial condition, constant has the meshing and the fluid properties, and system has the time and discretization thing. So in last class, if you remember, I told you that in system you are going to have a blockMeshDict. So if you are creating the mesh using the blockMesh utility of the OpenFOAM, then there must be one file name as the blockMeshDict. So in this lecture, we are going to just talk about that blockMeshDict utility. Okay. So blockMesh is the based on blockMesh is based on the multi-block base type of meshing. So what blockMesh does? So suppose you have some kind of block geometry. So you want to mesh this geometry, this complete block you want to mesh. So blockMesh what it does? So it just break this complete block into the smaller block. So one block will be here, one block will be here, one block will be here. This kind of smaller block has been created if you want to mesh this block using the blockMeshDict. So and another thing is that it always create the hex type of meshing. Hexahedral meshes it always create using the blockMeshDict. Okay. There are other types of utility also present in the OpenFOAM like snappy hex meshed. So snappy hex meshed, suppose you have some kind of complex geometry and you want to mesh around it, then this snappy hex mesh utility can be used. So what does it do? What it does, it generally the split the meshes around this object, and then again we refine the meshing around this object, and then after refining we just snap the meshing to the surface only. Okay. So what I am saying you will understand when I will talk about the snappy hex mesh utility. There are other utilities also like foamy hex mesh and foamy quad mesh that can be also used if you want to mesh some complex geometry. Even if you are using some external if you are using ANSYS or you are using Gambit or using GMSH, then that meshing can be exported, and after exporting you can directly use it in the OpenFOAM. Okay, so these all aspects we will discuss, so don't worry about. Currently I'm just focusing on the blockMeshDict. So if you want to start with creating the geometry and you want to simulate some simulation in OpenFOAM, so these three things are the first step you have to do before starting the simulation. So first you have to create the geometry, then after creating the geometry you should have generated the mesh, and after generating the meshes, lastly you have to develop the boundary conditions. Okay, so these three things also can be done in a single block mesh file. So only block mesh, this all three things can be done in block mesh. That is the advantage of using block mesh. So if I don't know whether you have used ANSYS or not. So in ANSYS, if you want to create the some geometry or meshing, so ANSYS you have to first create the geometry, then you go to the meshings, then you go to the simulation. Uh, Here you can all done in a single file in the block mesh. So that is the advantage of block mesh, but there is some disadvantage also. So if you want to create some complex geometry, then blockMesh will take a very much longer. Even I can say that very complex geometry can not be created by using blockMesh very easily. So that is the disadvantage of the blockMesh. However, the meshing is done by blockMesh is the completely hexahedral, so it is the perfect mesh if you are using the blockMeshDict. Now in last class we have solved the 2D cases. So for present problem I am going to create this type kind of geometry. So in today class we are going to just create the 3D mesh. Okay, so here length is the 50, height is the 50 and thickness is the 5 mm. Okay, so if you want to create such type of block, so it is kind of a cuboid. It is a kind of a cuboid. So if you want to create such kind of block, so you can see here that first we have to start with the points. Then after generating the points, we will just connect these points. And after connecting these points, we will tell the OpenFOAM say that this all connected point is the one block. So these three steps we are going to perform if we want to use the blockMeshDict. So for example, the same geometry has been uh, made like a block. So these are the 0, 1, 2, 3 are the four vertices on the right side, and on the left side 4, 5, 6, 7 vertices. So you can see here that there are total 8 points. So in OpenFOAM, vertices are called as the points, and we are connecting these points. So 0 to 1, 1 to 2, 2 to 3. So one thing you should remember that while using the blockMeshDict of the OpenFOAM, that the block points should be mirror image of each other. So what I mean to say that suppose you are following the numbering like this 0, 1, 2, 3, that means that anti-clockwise, then 4, 5, 6, 7 should also be anti-clockwise. So the increasing number should be in the anti-clockwise on both sides. That is the call as the mirror image. So ordering is not important. Even you can start from here 0, 1, 2, 3, but mirror image should be important. So if you are starting from 0, 1, 2, 3, then here 4 should be there, 4, 5, 6, 7. That is also correct. So ordering is not even you can start from 0 here, 1 here. So ordering is not important, but the points should be mirror image of each other. Okay, so the mirror image means that 0, if you are starting 0 here, then the lowest number of this face should be start from here, and you are increasing one here, so here should be 5, 6, 7. So if you don't by mistake sometimes you miss numbered these points, then it is going to show some error. Okay, now you can see that in this block there are 8 points and 12 edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 edges, 6 faces, and the complete block is one single block. So these all things we are going to done in the OpenFOAM. Now there is one famous utility, you can write it on a paper, that is known as the foamCloneCase. So if you want to create some case from beginning, and you know the some where you are trying to create the start the case, then you can use that utility to just create new case of a similar kind. So the similar kind of case can be created using this command foamCloneCase. Okay, so for example here I want to create one new case that is similar to the flange case. So that is the location of the that flange case, and I want to create some new test case, and here naming can be anything. So this is the utility, you can create any new kind of test case. Now you can use any type of editor for editing. I am using Genie. So Genie is the very good utility, or I can use Vim. So any kind of editor you can use based on your preference. So let's create the blockMeshDict for this geometry. Then we will go for the cylinder. Okay. So here if you want to just visualize these points with the numbers, so this is the utility that is helpful if you want to visualize the just vertices numbers. So what I want to say that you are going to see in the test case. So let's go to the Ubuntu terminal where we have already come here, and I am going to create one folder name as tut2. Okay, let me increase the uh, text size because it's very small. Now I think it is okay. So we have created one folder name as tut2, and you can see here that there is already tut2 has folder can be created. Now using the cd command we will go to that folder that is known as tut2. So here you can see here that there's nothing present in this folder right now. Okay, now if we want to create one test case having the blockMeshDict file. So let me check that where any folder naming the blockMeshDict any test case is present in OpenFOAM. So I will directly clone that test case in our this current folder. So for that purpose I will open another window and let me just zoom it out. Now direct I will just create the OF6 command, so it will create the OpenFOAM environment. Now I can directly go to the foam tutorial case by typing this. Okay, so I will just directly go to the tutorial folder of OpenFOAM by directly typing the cd and foam tutorial commands. So now he can can see here that we have directly entered that OpenFOAM tutorial files. So just by typing cd foam tutorials, you can directly go to the this complete tutorial folder of the OpenFOAM. Now we are going to find. So I will use the find command, and there is what you want to search that you have to type iname, and I will type the blockMeshDict. So what does it means? That I want to find with the name of the find a file with the name of the blockMeshDict. So this is the meaning of this command. So it will search all the folders present here, and it will find that where the blockMeshDict file is present, and it will show the location of those folders. So you can see here that these all folders having the blockMeshDict file. So this is the showing the location of all the files having the blockMeshDict file. Now we will just copy the cavity case because it is the simplest case, and our problem is simple, so this is the more useful for our test case. So we will just copy here the location, and let me go to the here only. Now I will use the command, but before that I have to create the OpenFOAM 6 environment. So I have created the OpenFOAM 6 environment. Now if I type foam cl after typing foam clone, and if I type tab, it will automatically complete the command. Okay, so after typing foam clo, if you just press the tab, it will automatically complete it. Now I have to show the I have to tell him that, okay, sorry, so I have to tell him the location of the folder. So I want to create the test case of the cavity like of test case, and I want to give him a location that is the foam tutorials space. So I have typed the typed the foamCloneCase command, and after that I will give him the location that you should go to the OpenFOAM tutorial folder, and after OpenFOAM tutorial folder there will be one folder name as incompressible, and in incompressible folder there will be folder name as icofoam, and from that icofoam you have to copy the cavity test case, and I want to name that the cavity test case as 3D. So see, it is saying that copying directory from this location to this location to our location. and the location is the 3D folder. Now if you type ls command, now you can see here that 3D folder is present here, and also you can go here and you can see here that the 3D folder is present here. Okay, so for now, as for now, our test case has been copied here, cloned here, you can see here. Now we need to go to the blockMeshDict file folder. So for now I am just renaming this 0.org. Okay, so because we are not going to use this for now until and unless our mesh will be created. Only after creating the mesh we are going to use the 0 folder. Before that there is no need of the 0 folder, so that's why I am just renaming it. You can rename it anything, like you can rename it as 0.pkp, any name you can give here, but only important thing is that 0 folder should not be present here. Otherwise when you are going to use the paraform, it will going to show the error. Okay, why it is going to show the error? Because in our boundary case, boundary name, whatever we are going to give the boundary name, that 0 condition is not present in the p folder. So suppose I have started creating the blockMeshDict based on our choice, and I have given the name here min x, and here it is showing the moving one. So in 0 folder it is showing the moving one, and here you are giving the min x or min y. So when you open the paraform, it will show the error that this boundary condition is not present in the p folder. This kind of error it is going to show. So to avoid such error, I have just commented that 0 folder. Okay, so I am just get rid of until and unless I created my mesh using the blockMeshDict. Okay, so now I am going to start with creating the blockMeshDict. So this is the blockMeshDict file. So better choice that you just first comment of all this. So I'm commenting off because some some comments we are going to require here, so that's why I'm just commenting off. Once I will create my blockMeshDict folder, I will going to delete all this, but until and unless I have not completed this, I'm just commenting off because maybe some of these codings may be required for our blockMeshDict. So that's why I'm just commenting off. Once I will complete my blockMeshDict file, I am going to just remove all this. Okay. So let's start with this. So when you open the blockMeshDict file, so there will be one uh, command that is known as convert to meters. So what is the convert to meters? So convert to meters means, suppose my thickness is, like in our case here, the thickness is 5 mm and height is 50 mm and length is 50 mm. So better if I can use the meter scale, and I have to just use the 50 mm, write the 50 mm as 50 bhaga 1000. So this will be like 0.005. So if I write convert to meter is equal to 1, then every unit mm centimeter I have to convert it into meter, then I can use here. Okay, so either you can do like this, otherwise you can just make the whole blockMeshDict file into the meters. So I will just by writing 0.01001, I tell that the by default unit of the blockMeshDict is the mm. So it is going to understand in the mm only. Now I have just make the unit of the is equal to mm. Now I will start with the 0. So 0, the location is the 0, 0, 0. So first I will give the vertices coordinates equal to 0, 0, 0, and that is the 1. So first we are going to create this 4 point 0, 1, 2, 3. Then after these 4 points we are going to give these 4 locations. So this has the 0 0 0 1. Now if you go to the one, there will be 50 mm. Okay, so this will be 50 mm. So I am taking this direction. Okay, let me write with the, or we can take it x, we can take it y, and thickness I am taking as only z. Okay, this will be better. Okay, so this thickness I am taking z, this I am taking x, and this I am taking y. You can take any coordinates, it does not matter. Just you have to follow the, stick to the rule what I am telling you. So in x direction I have 50 mm thickness. So after 0 0 0 the x will be changed to the 50. So here the that will be 50 mm. Now this will be our second coordinates. I think this you can remove here because here we are not going to use these points. Okay, so this is now our two second vertices. If you go to the two vertices, okay, so I forget that I have told you that the numbering starts from 0. So here it will be 0, it will be 1, and it will be 2. So for 2 point, you know that this is x is 50, y is 50. So that will be 50 comma 50 comma 0. So I will write here 50 comma 50 comma 0. Now if you go to the third point, so I will write here 0 comma 50 comma 3. Okay, so I've created the four coordinates 0 1 2 3. Now I have to create the 4 5 6 7. Okay, so in, if you see there, that is the mirror image of 0 1 2 3 4. So this 4 5 6 7 is the mirror image of 0 1 2 3. So we have to just only change the z coordinates. Okay, because it is the mirror image. So x and y coordinates are the similar to the 0 and 4 have the similar x and y coordinates. 1 and 5 have the similar x and y coordinates. 2 and 6 has the similar, and 3 and 7 has the similar. So only z coordinates will be different. And what is the z coordinates? That is the thickness of the plate. So these things we are going to write in the blockMeshDict folder. Okay, so for that purpose I have to just copy this because x and y coordinates are similar. So we are just going to change the z coordinates. So instead of 0 we will write the 5 here, and these points will be 4 5 6 and 7. Now if you want to visualize the points here, you can just go to the, and you can write the this command, parafoam block command. So this parafoam block command, it will visualize the, it is going to visualize the all these vertices here 0 1 2 3. The numbering will be shown. If you want to see those numbers, you can use the parafoam block command. Now you can hear that, you can see here that these numbers are seen here. If I change the color, so you can see at the 0 1 2 3 and 4 5 6 7, these numbers can be seen here. Okay, so by using this parafoam block command, you can see these numbers, these blocks numbers. Now if you want to create the blockMeshDict, so for that purpose you can use this hex command. Similar, that's why I commented here. I've just copy these points and just printed here. So you can see here that this is the numbering 0 1 2 3, and 0 1 2 3 is the mirror of the 4 5 6 7. So this numbering should be important. This should become keep in your mind that this points should be mirror image of each other. Okay, so 0 1 2 3 is the mirror of 4 5 6 7. So this is the way of writing the hex these things. Okay, now I have I have written these lines. Now I want to create the boundary here. Okay, so that's why I will copy from any last tutorial. It's better to copy it from the last tutorial. So I'm taking from here, and from anywhere, any blockmesh file, you can just copy one column and paste here. Okay, so just for the ease of time saving, I'm doing like that. Okay, so if I open this blockMeshDict file, so you can see here that I am renaming 0473 as a miniX. So 0473 as a miniX. Now let's copy and paste here, and I'm again writing one max x as a boundary condition. So this boundary condition I will named as a max x. So 1365 1365 I named it as a max x 1365. Now let's copy this whole these two things and just comment it here, and now write it as a min y and max y. Now I will write this block this face as a min y. So that is the 0451. That is the 0451. So I will write here 0451, and similar to 0451 I will write it here as 2673 2673 2673. Again I will copy complete and paste here for z direction. So I will write here as z, and this one is the z. Now this min z is the this line 2301, or you can write it as 0123. That is also perfect. So you can write here 0123, and similar to 0123, this will be of course 4567, because these 2 points are the mirror image. 4567. So we have also written the boundary condition. We have given the block name. We have created the block here, and we have given the vertices here. Now we can run the blockmesh command. So there is one mistake. It is showing that this point is mistake 1365 is there is no any face like that. So for that purpose we are going to just see uh, where are these mistakes happening. So I'm just writing the paraform block by after commenting the boundary condition. If you don't comment that boundary condition, then you will going to say get the error like that. See this error. So even if you want to use the paraform block, so you are going to this error only after commenting this boundary naming. You can visualize it in the paraform block. Now if I see here, so I want to see which point 1365 it is showing the error. So if I see here that which boundary condition I'm giving, this is the max x. So one you can see here that should be 1265, not 1365. That's why we are getting the error. This points, this face only you can mention by using the 1265, not 1365. That's why it is showing the error. So we will write here the 2. So it's good here that we get one mistake, and that's why you have idea about that. If you want to see what mistakes you are getting, you should get, you should visualize using the paraform block. Now you can run the block mesh. Now you can see here that this patches name size has been created. Now you can see here that this number of cells are 6400 cells we have created here. Okay. Now if you want, you can now visualize in paraform directly. So this is our block and this is the meshes. This blocks has been split into the smaller faces, smaller cell, and this smaller block is called as cells. Now if you want to run any test case, like suppose in from since last, similar to last class, you want to run the test case, so I will copy 0 folder here, and since we want to run the Laplacian form, so since similar, we need this temperature folder here, so I will copy this temperature folder in this present folder, and I think we don't need this two folder here because in Laplacian form there is no u and v, and since we are using the FV scheme and FV solution of the Laplacian case, so we are going to copy this FV scheme and FV solution also there. Okay. Now if you visualize the temperature folder, this is the temperature folder and this is the boundary folder after running the blockMeshDict file. So both should have the same number of boundary condition and same type name also. Okay, so you can see here that this is a type name, and since this time we are using the 3D case, so now this condition should be not of type empty. You can use the type empty only if you want to use the 2D cases. In 3D cases there is no need to mention the type empty. Okay, so the type empty boundary condition only used for the 2D cases. So this everything has been set up. You can now run the Laplacian form. So you can see here that the solver has been run, and hence you can start working with the any type of the test case using the blockMeshDict. So I think this tutorial is helpful for you, and in next tutorial I am going to explain how to create the cylindrical type of geometry using the blockMeshDict file. So there are two methods by which you can create the cylinder type of geometry, and that two method we are going to discuss in the next lecture. So thank you to all of you for watching this video.